Today I'll be talking about rush lifetimes. Before I start explaining rush lifetime, I would highly recommend you to watch this video from Doug Milford. I have referred many articles and videos and couldn't really understand what rush lifetimes are, but this video really helped me to cement the knowledge. I won't say I am expert in rush lifetime, but I could get the general idea about it. So if you're interested, definitely watch out this video. Now coming back to topic, lifetime is only about references. Any reference parameter that is never returned as the output. The rush provided default lifetime is fine. So constants, I have defined two constants. By default, constants do have lifetimes and they are static lifetimes. Next, I have defined a variable let a. Inside, then I have defined the scoping block. Inside that, I have defined another variable b. Then I am assigning b to a, which is correct. But suppose if you comment out the second line of assigning a to b and you just assign a reference of b to a, that is incorrect because b gets destroyed as soon as the block is over and a can't reference it. Next, I have created a method getInRef which returns a point reference. Now I have created a variable inside that method and I am returning that variable reference. This is called as dangling reference because a gets cleaned up as the method gets over, so you can't do something like this. And next is getInRef. I am returning i32 and in the function also I am returning a. This is fine as we are no longer holding on to the memory. Now I have defined another method called getInt. I am defining it takes a input param1 which is a reference and its output is also a reference, so lifetime will be applicable. And in this case I am just returning the input back because the function is not the creator of this param1. The param1 comes from some other main function or some other function, so getInt doesn't have to worry about its lifetime. So param1 does not get destroyed when getInt finishes. So the above same method, uh, so the Rust compiler will automatically add lifetimes even if you don't add it manually. So here you can see the tick a or the apostrophe a. I will call it as tick because that's what the doc says. Here it is a tick a and we have one input parameter as a reference, right? So it will have one lifetime, so that is tick a, and we are referring returning a reference which is the same. That's why the reference is also returning reference also has a lifetime of tk. The above function is seen as Rust like this. Tk is the lifetime, but for this function we don't have a lifetime as Rust is smart enough to deal with it. The problem occurs when you have multiple input params and returning only one references. Check below function. So I have another function called findGreater. I have defined two inputs and I am returning a reference. Now Rust will throw an error because it can't figure out which reference are you trying to return back. So to solve this problem you have to manually specify the lifetime specifier like we did for above function. Now here you can see I have defined tick a, then comma tick b. Forget about the colon tick a for now. Suppose it has only tick a comma tick b, then inside param1 is tick a, param2 is tick b, and I am returning tick a as the output. So Rust is fine, okay, but as soon as you return param2, Rust throws a warning saying you told that you are only returning tick a as the return type, but you are sending back param2 in the else clause, which is not correct. So to avoid the issue we are saying that tick b colon tick a when we define the function, which means that tick a and tick b both have the same lifetimes, which means they suppose they are defined in the main function. There are two variables param1 param2 defined in the main function, so both are defined in the main function and will get destroyed when the main function finishes, so both of them have same lifetime. Next I have defined another method findGreater which has a tick a And here, instead of defining two lifetimes, I have defined only one lifetime, even though there are two input parameters. You can do this because param1 param2 have both have same lifetime, both might be defined in the main function. If it's possible that main first input is defined in param1 is defined in main function and param2 is defined in some other function, then this won't work. But we know that param1 param2 are defined in main function. uh, we can have only tick A, we don't have to worry about tick B. Next, I'm taking three input parameters. Two are references, last one is direct a normal value. So I don't have to assign lifetime to it because lifetime are only for references. Even the return type, if in this case the return type is a reference, but if it wasn't a reference, then I don't have to assign a lifetime to that return type as well. So here you can see the input type is return type is I32 and not a reference. So the lifetime, we don't have to assign lifetime to return type, and the lifetimes which are assigned to param1 and param2 will get ignored because Rush doesn't have to worry about it. We are not returning param1 or param2. Then static lifetime means a lifetime that lasts the entire program. Constants are static by nature. You should use static as a last resort. So I have some function param1 param2 and it takes two static strings which are the constants we have defined earlier. You can pass that constants and it returns a static reference as well. So because both are defined in the same scope, both constants, they have been assigned the same lifetime of static, and then we can return whatever parameter we want to. So yeah, that's it for today's video. Thank you for watching. Bye.